Hello, and welcome to today's ACM Tech Talk. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of nearly 100,000 computing professionals and students. I'm Keith Miller, the Orthwein Endowed Professor for Lifelong Learning in the Sciences in the College of Education at the University of Missouri St. Louis. My research interests include computer ethics, the use of technology in education, software testing, and codes of ethics. I also serve as the secretary of the ACM Committee on Professional Ethics. You can find more about my background in the bio widget on your screen. For those of you unfamiliar with ACM or what it has to offer, here's some more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving innovations that sustain competitiveness in a global environment. ACM provides timely computing information published by ACM, including Communications of the ACM and Q magazines. Access to the ACM Digital Library, the world's most comprehensive database of computing literature. International conferences that draw leading experts on a broad spectrum of computing topics. Support for education and research, including curriculum development, teacher training, the ACM Turing and ACM Prize in Computing Awards, and the updated ACM Code of Ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, I'd like to quickly mention the housekeeping items shown on this slide. First, the slides will advance automatically throughout the event. On the bottom panel, you will find some additional widgets and resources. If you are experiencing problems with the slides or the audio, press the F5 key in Windows, Command+R if you're on a Mac, or refresh your browser on a mobile device. Or you can close and relaunch the presentation. To control volume, adjust the master volume on your computing device. If you have questions during this talk, please type them into the Q&A box at any time and click the submit button. I'll organize some of those questions as Don and Marty speak, and they'll reserve time at the end of the presentation to address some of your questions. This session is being recorded and will be archived. You will receive an automatic email notification when that recording becomes available. And check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill it out and help us improve our tech talks. You may also open the link to the survey at any time from the resources window. You can use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag #ACMLearning. We'll be watching for your tweets. We also have a community discourse page to continue the discussion after this webcast, including questions we won't be able to get to during the Q&A session today. Today's presentation is Leveraging the ACM Code of Ethics Against Ethical Snake Oil and Dodgy Development. Don Gotterbarn has extensive experience both in academia and as a software systems developer. He has spent decades promoting responsible computing practices, including as director of the Software Engineering Ethics Research Institute and as a visiting professor at the Center for Computing and Social Responsibility in England. He has taught at institutions like the University of Southern California, at government agencies like the NSA, the Australian Department of Defense, and was a visiting scientist at Carnegie Mellon's Software Engineering Institute. He led the 2018 update of the ACM Code of Ethics and the development of the IEEE ACM Software Engineering Code of Ethics and Professional Practice. These contributions to responsible computing have resulted in him being awarded the ACM Outstanding Contribution Award in 2005, the International Society for Ethics and Information Technology Joseph Weizenbaum Award in 2010, and the ACM Presidential Award in 2018. Marty Wolf is a professor of computer science at Bemidji State University. He has more than 30 years of experience teaching undergraduate computer science and has published research in theoretical computer science, bioinformatics, and graph theory. Over the last 20 years, his research has focused on collaborative projects in computing and information ethics and the philosophy of computation. He has developed and taught a standalone computing ethics course to computing science undergraduates, as well as computing ethics courses for non-CS majors. Along with Don Gotterbarn, he currently co-chairs the ACM Committee on Professional Ethics and was part of the team that led the recent update to the ACM Code of Ethics. Marty has extensive experience on interdisciplinary projects that involve the teaching of computing ethics. He is currently co-PI on a grant from the Mozilla Foundation to develop mechanisms for computer science faculty to better incorporate social and ethical issues into standard computer science projects. Don and Marty, without further ado, take it away.
Thank you, Keith. I noticed you enjoyed emphasizing the word decades. Professional computing, computing ethics, or at least talking about it, has become a cottage industry. Some people are selling ethics as a snake oil that will cure everything. This is especially true in certain areas of computing, such as AI and big data. There have been over 150 different codes of AI ethics generated in the past 2 years. But like a snake oil salesperson, having many codes of ethics can distract and overwhelm you. Other segments of the industry, such as avionics and voting machine systems, take a more dodgy approach that is more focused on testing. They test their own systems, and then they assure us that the software passed their tests. And of course, since the system is proprietary and not available for inspection, concerns arise, especially when the system behaves in unexpected ways. In one county in South Carolina, voters can select 2 candidates for a particular office, but the voting machine software only recognized a vote for a single candidate. So the software took the voter's second choice and added that to a different race, resulting in the candidate receiving more votes than there were voters in the county. These sorts of events cast shadows on the computing profession and lead to accusations of malevolent producers. Obviously, this is not an accurate characterization of most computing professionals. They want to get things done and do good things. There's clear evidence of this in the work ethic held by developers in most programming shops and those who contribute to open source software. Nevertheless, unusable software gets produced, or worse, sometimes software that reliably and consistently causes harm to individuals or groups gets released. In the most insidious cases, software that subtly and unknowingly promotes harmful changes in the structure of society is marketed and sold.
These things stand in contrast to the goals of the ACM. Among the purposes listed in its constitution, the ACM is, quote, dedicated to serving both professional and public interests by promoting the highest professional and ethical standards, end quote. Maintaining its code of ethics is merely a first step in fulfilling this purpose. In this talk, we will further that purpose by presenting techniques to mitigate factors that contribute to dodgy development and better, encourage positive computing. These techniques are based on research on some causes of the sorts of difficulties mentioned earlier. These recommendations are for everyone involved in the software development process. First, though, we take a look at some of the factors that contribute to the complexity of establishing high professional and ethical standards. The nature of engineering large software systems, as well as integrated system software, is inherently complex. Complexity is nothing new for engineering projects. However, unlike engineering a bridge, car, or ventilator, software takes on features that function in a more continuous rather than discrete fashion. In discrete projects, the whole can withstand a minor mistake somewhere, a weak rivet in a bridge truss, or a slightly ill-fitting gasket. Software projects, in contrast, can be brittle and not at all resilient to even minor flaws. This complexity of software systems is a challenge. A software professional may find that challenge daunting, but also exciting. Solving and managing complex problems is satisfying. On the other hand, complexity can easily cause us to narrow our focus to just the competent completion of the product. Competence is good, a narrow focus is not. If we overemphasize reducing software complexity to discrete manageable elements, we run the risk of losing sight of the broader complexities. We always need to consider a system's impact on a broad range of stakeholders. When offered the helpful task of developing a contact tracing app to reduce the spread of COVID-19, the technical complexity is an immediate consideration. Yet, we need to ask, what impact will this have on privacy? And whose privacy will be most adversely impacted? We should always be willing to question whether a particular system should be developed at all. Whatever software we develop will affect a broad variety of stakeholders. We need a process to ensure that the technical complexity does not become the primary consideration. The public good should always be the primary consideration.
Not considering all stakeholders is especially dangerous for any human-facing software. Understanding how real people in real situations will respond to the software and its behavior is no small feat. In the design of a cockpit interface, a mixed-mode display unit was used to convey two different pieces of information. One was the vertical speed at which the altitude is changing, and the other, the flight path angle of the craft. Minus 3.3 with a decimal point meant it was descending at an angle of minus 3.3 degrees, while minus 33 meant the plane was losing altitude at 33,000 feet per minute, thus not clearing a mountain in Italy. In the plane crash in Italy, evidence indicates that the pilot misread the data and probably did not notice the presence or the absence of a decimal point. It's not easy for anyone to see the presence or absence of a decimal point, especially in the complex environment of a cockpit. The values of the cockpit gauge were correct, but the interface made the information difficult to discern. Sometimes known errors generate incomprehensible error messages, and sometimes that happens in very inappropriate contexts. The competent completion of both of these systems may have met their technical specifications, but they were failures because they did not meet the less obvious ethical requirements.
The goal of competent completion is deeply ingrained in many software professionals. The focus on completion starts in our computer science classes. Finish one programming assignment, deliver it to the professor, and then start the next one. This manufacturing mindset of getting the product out the door quickly and valuing the quantity of product produced generates problems for software development. A key problem is a failure to realize that software development does not generate an independent standing manufactured product. The manufacturing model often rewards first to market with sufficient product produced inexpensively, as long as minimal requirements are met. By minimizing testing, schedules are more easily met and costs are reduced. Unfortunately for software users, cutting the time for careful design and testing results in a less resilient product. A special challenge for the computing industry is to undo this manufacturing mindset that starts in the university. Another problem that stems from the manufacturing mindset of equating quality with quantity are certain measures of coder productivity. Code Vicious makes this point in a recent issue of ACMQ. Quote, "Many silly metrics have been created to measure work, including the rate at which tickets are closed, the number of lines of code a programmer writes in a day, and the number of words an author can compose in an hour. All of these measures have one thing in common. They fail to take into account the quality of the output. If Alice writes 1,000 lines of impossible-to-read buggy code in a day, and Carol writes 100 lines of well-crafted, easy-to-use code in the same time, then who should be rewarded? Computing should not be evaluated like piecework. The first choice is to game the system such that you can actually do minimum work and get the maximum benefit, usually by taking on trivial tasks that can be easily completed, and will show at the end of each month that you have accomplished more tasks than anyone else." End quote. In addition to not rewarding good coding, applying the manufacturing mindset to developer evaluation actually creates a perverse incentive to worry about things other than the quality of one's code. People will succumb to this incentive since it is human nature to produce more of something if that is the thing they are getting paid for. Rather than use a compiler to unroll a loop, the developer makes more money when they unroll a loop themselves. Creating verbose documentation that distracts from understanding the system is more lucrative. Spending time fixing or improving code is at best not rewarded and at worst actively discouraged. After all, if code works and produces any results, then that is all that matters. In such an environment, an ethically astute developer is seen as unproductive. What are we talking about when we talk about ethics? One unhelpful view of ethics equates it with legal compliance. For example, ethics can be reduced to a dollar limit on gifts an employee accepts or solicits from clients. Some companies introduce 1 hour of ethics training annually to qualify for a reduced judicial financial penalty if they are caught behaving unethically. An ethical checklist may offer some useful reminders, but it is never sufficient. Another misuse of ethics is ethics washing or ethics theater, where companies give the external appearance of being very concerned about ethics to avoid the application of external regulations, and yet not do anything to mitigate or respond positively to those concerns when they do arise. For example, promoting AI for good while developing and selling questionable surveillance software is ethics washing. This approach creates dissonance for the computing professional. Often, ethics theater is in play when a corporation caught in a scandal then creates an ethics board or an ethics compliance officer position.
Adding to these misuses is the baggage of the term ethics itself. It's often thought of as merely the many ways philosophers have studied systems for centuries. Many computing professionals feel ill-equipped to engage in that arena and find it not relevant at all to their critical applied decision-making. If ethics is only for philosophers, computing professionals need not be involved. Yet, we make ethical decisions every day. A workable approach to ethics for us is to consider it as any behavior that impacts other people or society, positively or negatively. Ethical decision-making is something we always do, and it involves our ability to imagine the effect of a behavior on others' lives. Our professional decisions have ethical impact, and that needs to be recognized. Terry Winograd distinguished between ethics and applied professional ethics using a term he invented called ethicking. Ethicking is a verb, and it describes how a computing professional starts with a set of values found in the ACM Code of Ethics that guide their day-to-day activities. Further, ethicking distinguishes ethics as a static domain of academic study from the professional activity of interpreting, choosing, and assessing our activities, where we distinguish what is always done from what really should be done. Since everything we do has consequences, ethicking should be routine for every computing professional. Unfortunately, there is yet another complexity called the fatal premise.
For many people, the right thing to do seems obvious. Our ethics start with past experiences, from things we learned from our parents and religious texts to the constant social cues around us. However, issues in computing ethics are often new and require thought beyond our immediate intuitive ethical responses. After all, few religious texts mention Twitter. In a talk on professionalism in computing, Tom DeMarco described a position that often leads to ethical issues. He called it the fatal premise. Often people believe evil is done by evil people. I am not an evil person, and therefore I cannot do evil. Professionals who take this view go into the world ethically unprepared and may simply complete a system without taking the extra time to consider its impact on a broad range of stakeholders. A silly example of the fatal premise is an unsecured Bluetooth app that is used to control water flow and temperature for a bidet. But the designers never considered the disgruntled spouse or malevolent neighbor who might choose to scald someone or cause a mess when the bidet's owner is away. The actual stakeholders were not considered in the design. Fundamentally, a professional who adopts the fatal premise has an ethical blank check. The professional believes that anything they do will be acceptable because they are a genuinely good person.
Psychological studies on ethical decision-making show that DeMarco's fatal premise is very common. This premise is unfortunately nurtured when an organization puts its primary staff development focus on technical skills acquisition. Training on how to consider the impacts of technical decisions on society is left at most to being an afterthought. Without consistent training in considering the impact of technology on people, significant issues may be missed. Sometimes computing systems fundamentally change the nature in ways we did not consider. It's easy to imagine a medical diagnosis system changing the way doctors make care decisions because it changes their liability calculus. The management of ethics can be further complicated by a mistaken belief that being ethical does not contribute to a company's bottom line. Yet, research has shown that there are clear ways that ethics does contribute to the bottom line. A robust ethical culture contributes to company loyalty, both from the workers and the public. A company that values the ethical can reduce costs associated with rapid employee turnover. Customers and the larger public respond better to an ethical company. Trustworthy companies who produce trustworthy products may be able to reduce their advertising budgets. All of this helps the bottom line. One of the ways we in computing manage complex problems is to engage in a divide and conquer methodology. We narrow our focus of complex elements of a problem to very small areas. This allows us to frame out distractions, and that's a plus. But we know from our daily lives that mistakes are often made because questions get constrained by a particular frame or filter. It's happened to bring in talking about recycling as an environmental moral exercise is something many communities have done. When they do it, it happens to bring in some money. Now recycling makes less money or even costs money. And if moral responsibility is framed out of the question of recycling, and the expense of recycling programs becomes the overwhelming driver for that decision, then recycling will stop because the moral imperative is forgotten. When we think only inside the technical box, we fail to notice the ethical component of a decision. We can behave unethically while maintaining a positive self-image. This framing out of the social and ethical issues, when combined with the fatal premise, leaves us engaging in or condoning behavior that we would actually condemn if we were consciously aware of it. The result is that we do not see our behavior as anything to do with ethics, but as something else, acting from our agency, acting strategically, pushing financial costs and benefits, pushing a personal agenda, doing what we are required to do by law, doing what it takes to make us look good. This framing out has a psychological basis. Psychological studies have found that our immediate ethical reactions, which involve rapid intuitive processing, occur frequently before a more worked out ethical decision making that is slower, more conscious, and more logical. Ethical decision making processes take cognitive attention in order to consider aspects beyond the way in which situations are framed for us. It takes cognitive attention to consider relevant ethical elements, to analyze the impact of those elements, to review pertinent responsibilities, authority, and alternate approaches, and to evaluate all of these alternatives. Ethicing requires an analysis of the impacts of a system on a broad range of stakeholders. Every line of code we write affects others. How we test a system impacts others. This framing out problem is not limited to individuals. Organizations have a similar framing out problem that often leads to operating under a false dichotomy between business decisions and ethical decisions. When an organization frames everything with a financial filter, it doesn't have a chance to recognize opportunities to make decisions ethically. This false dichotomy harms organizations. It was against this backdrop that the ACM Code of Ethics and Professional Conduct was updated a few years ago. The update process was much like software development. Each of 3 drafts was shared publicly and broadly. Feedback from computing professionals and other interested stakeholders across the world contributed to the improvements in the next draft and so on, resulting in a final version which includes passages written by those stakeholders. The code expresses the conscience of the computing profession, and it is a call to ethicing. Recall that ethicing is a process of interpreting, choosing, and assessing our activities as professionals. Although people bring different experiences to ethics to their work as computing professionals, being a computing professional is one thing that we have in common. The Code of Ethics captures this. However, it alone is not enough to make ethicing happen. Our simple tool, consider, analyze, review, evaluate, is a reasoning process that leverages the code into the development of better computing systems and a better world.
In what follows, we lay out using proactive care for individuals and teams, and then identify ways that management can support the care process. With proactive care, individuals, teams, and organizations all contribute to an environment that increases the chances that the fatal premise and the framing out problem are recognized as a real threat to doing the right thing, even though everyone is on board with doing good work. A habit we encourage is always being ethically on guard. This is not a skill to be taken lightly. It takes practice and cognitive attention and energy. To help get started, we provide some techniques that help identify ethical issues. Consider. Remember that if the code you are writing is worth getting paid for, it is going to affect other people. Consider whose behavior and work processes will be affected, whose circumstances or job will be affected, and those whose experiences will be affected. With these considerations, you begin to identify stakeholders who ought to be addressed. Bearing the stakeholders in mind, consider alternative approaches to constructing the system. Analyze. A good place to start analysis is with the Code of Ethics. Take a look at it from time to time, keeping in mind that it is a holistic document that expresses the moral values of the computing profession and informs professionals of their obligations to the profession and to stakeholders. Analyze the technical facts of the system and the consequences of each of the alternative approaches for each stakeholder. The Code of Ethics provides support here, but be careful to avoid the framing out problem. Focusing on a single principle can lead to an analysis that misses important considerations. One might be tempted to focus, say, on Principle 1.6, respect privacy, when developing a contact tracing app, but other principles, such as Principle 1.2, avoid harm, apply in that situation as well. Review. Analysis leads to identification of the trade-offs of the alternative approaches and identifies those that have a chance to make a difference. Review those alternatives. Are there creative alternatives in addition to those that you have considered so far? Now is a good time to loop back to consider and analyze before you proceed. By reviewing potential actions relative to the principles in the code, you have reasoned through issues using an international set of professional values. Evaluate. Identify the best approaches and articulate their strengths and trade-offs. There is likely tension surrounding the potential actions and even among the principles from the code. There may not be an optimal choice, merely ones with different trade-offs. Acknowledge the knock-on effects of each of the choices, knowing full well that you may not have them right. These tensions require some stamina to follow through. Furthermore, evaluation requires continued monitoring of any decision in order to determine if it was a good one and to learn from it. Consider the seemingly simple choice of choosing a font and font enlargement function for a contact tracing app. It is certainly the case that if responsibilities like this fell solely on a single developer, it would be a heavy lift, especially if their expertise was in mutation testing or Rust. Those skills don't readily translate into ophthalmological knowledge about the potential harm of a font choice for someone with dyslexia. By recognizing the limitations of one's own expertise, it is natural to bring the results of your proactive care to the attention of your team and seek a broader range of expertise. Teams need to recognize that computing systems are socio-technical creations. Part of their responsibility is to involve others with appropriate technical and ethical expertise. As developers, we know that testing only at the end of the development process is bad software development. Testing is best when it is integral and ongoing. In the same way, giving consistent and regular consideration of social and ethical issues throughout the process leads to better software systems. Teams apply care in ways that individuals do, but there are additional considerations for the team. Consider. Teams need to identify all of the complexities of the problem. Recognizing that computing systems are socio-technical systems, good design dictates bringing appropriate expertise. In writing software for a pacemaker, we would first seek specialized help in determining the duration and amount of voltage to send to a patient's heart. Knowing about the heart was not part of our computing education. Additionally, teams need to consider whether the fatal premise, evil is done by evil people, has made an appearance. Analyze. Analysis of the team process is important to ensure that the team has not been overtaken by the march to competent creation. Analysis also includes careful attention to the framing out problem. The analysis should identify relevant actors, stakeholders, rights, obligations, and values that haven't been considered and ought to be. This kind of analysis should be received as a way to improve the product. Review. Typical software development includes a review of what team members have done, testing for different stress factors and timing issues. Review by teams includes using the code of ethics to spot ways to make the system better for others. Review how the system might be used and impact a broad range of stakeholders, such as users with a disability. Review design alternatives from various stakeholder perspectives. Evaluate. Evaluation is not about ego. Different alternatives bring different options to the team. There will be tension among the options and among team members. Identifying those tensions and the trade-offs among the alternatives leads to clearer thinking about the decisions to be made and contributes to selecting a technically and morally workable alternative. Using proactive care in the system development process reduces the likelihood of situations that would call for heroic measures by individuals or the team. It is essential to monitor team decisions and practices in order to understand how they contribute to effective ethical system development. Even with these practices, a team is most effective when it has the support it needs from management.
This holistic approach we are advocating includes responsibilities for individuals and teams, and also for management. Section 3 of the Code of Ethics focuses on the responsibilities that leaders have to support software developers in their professionalism and to give the required attention to all stakeholders. An organization's ethical culture also requires support from the top. In the proactive care process, recognition of a broad range of stakeholders is essential. People should always be the central concern of computing. Beyond the general broader public, though, there is an important stakeholder group, namely the software developers themselves. The code makes this clear in how it calls for those in leadership positions to support the professional development of individuals. Advancing analytic skills is important, but doing so in a way that integrates the development of ethical abilities is essential. Management needs to recognize and promote technical and ethical growth. That cultural change has to involve the hiring process. Most commonly, the hiring process, we think, implicitly assumes the fatal premise. Potential employees are good people and already know about ethics, so they only need to have their technical skills evaluated. Some companies, however, have recognized that quality work requires more than technical skills and have introduced consideration of other important skills during interviews by asking different sorts of questions. Questions like those shown here address candidates' underlying awareness of ethical issues. Have the candidates address issues surrounding flexibility, curiosity, work ethic, and their commitment to develop their own ability to be ethically on guard. Ask questions beyond mere technical issues. Give them a problem to see if they are sensitive to issues beyond how to implement the code. For example, ask them to think about developing an application such as a timer for a ventilator so that it would automatically turn off for 3 hours after only 22 hours of continuous operation. What concerns would you have about doing this, you might ask them. Candidates may give technical responses about loops and control structures, but you should follow up and ask them to give responses that address the socio-technical issues. Turning off a ventilator? Ask about empathy skills. Ask for responses that give a solid sense of the potential for the candidate to develop into a valuable, ethically on-guard problem solver. In order to break away from the manufacturing model, software developers need to demonstrate that they understand that their work is more than meeting technical specifications. Using these types of questions helps to hire those who have a sense of ethical responsibility. But using and developing those skills ought to be encouraged and rewarded after people are hired. To reinforce the necessity of being ethically on guard includes ethical performances in ethics in performance reviews. A standard practice in a code review is evaluating the quality and adequacy of a program's code to accomplish a technical functionality. These review sessions can easily be modified to include a proactive impact analysis that promotes positive outcomes and mitigates negative ones for different stakeholders. As we noted earlier, ethicing is hard work. Like any other ability, it takes time and practice to get good at it. Line managers should treat discussions of ethics and socio-technical impacts more like a coaching session. Make it motivational. It's important that the process remains transparent, credible, and consistent for all staff. These sessions should be conversations where everyone can ask questions and request resources. It's important that the line manager take a leadership role in ethicing. Whistleblowing is understood as a behavior designed to protect citizens from misbehaving corporations. It is a strategy to use when it is actually evil people doing evil things. There is, however, a different sense of whistleblowing. Some organizations have set up a mechanism for what we're calling internal whistleblowing, where employers are given a voice without fear of retribution. Its implementation can be supported by an 800 phone line, a website reporting ethical concerns. In fact, companies have added a button to push-button phones that dial directly to the ethics officer. Anyone with a concern about a project could press the button and message the ethics officer. Upper-level management encouraged this behavior as a positive thing by valuing having the issue out in the open rather than let it fester due to an individual being uncomfortable talking with a line manager about it. This approach has the advantage of mitigating misunderstandings about the issue and disagreements about the best ways to resolve this. Looking around, we found at least one recent example that demonstrates some of what we've been advocating here. As Apple and Google developed the joint exposure notification API, they illustrated the positive impact of the process we are discussing. The exposure notification API was developed in careful recognition of the importance of its primary function, while also trying to minimize stakeholders' privacy issues. Apple and Google worked with public health officials and epidemiologists in its development. Quote, "Our two companies have worked together, reaching out to public health officials, scientists, privacy groups, and government leaders all over the world to get their input and guidance," close quote. Stakeholders include app users who can decide what personal information to share, and include public health organizations that can use their definitions of potential exposure and their standards of transmission risk. The companies have even encrypted the metadata to protect privacy. In anticipation of personal misuse of proximity data, they have prevented the use of the API by apps that were not certified. This design of the API has the effect of discouraging contact tracing apps that use the API from misusing geolocation data. And rather than just releasing the API on the world, they are in follow-up discussions with public health officials to improve COVID-19 mitigation strategies. Care is required to avoid narrowly focusing on a single ethical principle. This is not intended as a blanket certification of the products of either of these companies, but it is a striking example of a proactive care-like process performed in public when it really mattered.
Here are some good practices. These are meant to complement the ideas we have already presented. Use pre-commitment devices to mitigate the impact of the fatal premise and the framing out problem. As you begin a project, think about or even write out what you would be proud to hear in your project review. Identify what you would hope customers or other stakeholders would say about your contribution to the project. Pre-commitment devices can also be used in project plans. Placing Principle 1.1, contribute to society and to human well-being, in a project plan, and including a section of that lists code principles relative to the project, helps to create an ethical cognitive frame. Engage the team in identifying how those principles are relevant to the project. It is not legally binding, but it will reduce the impact of framing out ethical issues, is relatively inexpensive, and has significant returns. Finally, use the code. There are recent examples of employees who raised concerns over management decisions and pointed to the ACM Code of Ethics and Professional Conduct for support. By leveraging the code and its widespread international support, it is possible to positively influence internal decisions and practices.
It's possible, only possible, that there are actually some computer practitioners and organizations that are malevolent miscreants, where the fatal premise or unintentional framing out are not the cause of the problem. These are evil people doing evil things, and there is need for someone to take action. An unfortunate approach in these situations is the moral bailout, quietly finding another job, or worse, actually doing the dastardly deed they requested. There is, however, a broad range of approaches to these situations. A moral hero may express public outrage, but before taking the steps of whistleblowing, there are numerous other strategies. When the opportunity exists, it may be easier simply to ask management the question, what happens if the newspaper finds out we're doing this? or ask them, wouldn't we get more customers if we made public that we avoided this problem and made this improvement a selling point for us? Such simple, well-placed questions might bring about the desired change, and they may even get you rewarded for your insight and for warning the company about a risk. There are certainly places where software is developed for the wrong purposes, and those environments do require an ethical hero, someone with the chops to blow the whistle. We hope that those sorts of places are rare, and most shops are populated with good people who are interested in developing systems that are good for people. Our concern about dodgy development arises when folks unknowingly adopt the fatal premise and unintentionally frame out significant items.
The ideas we have outlined here for computing professionals and organizations can make a real difference and lead to better software and a better world. The ACM Code of Ethics and Professional Conduct gives voice to your values. Thank you.
Thank you, Don and Marty. Let's move on to some questions and answers, and we have dozens of excellent questions. We'll only get to a few here. First, a question is, can I get a hold of your PowerPoint slides?
I believe the short answer is yes, that they are going to be made available at some point after the conclusion of this presentation.
Similar question. Oh, go ahead.
The plan is to put them on ethics.acm.
All righty. And a related question, can I use the idea of ethics and ethicking in the class I teach on computer ethics?
Absolutely, yes. The concept of ethicking was written by Terry Winograd in an early article on computing, and it's a very, and we will have references up on the website that will point you to Winograd's article and the concept of ethicking. The principle, the beautiful thing that struck me about it is that people think about ethics as what's in the book on the shelf and what Plato and those other folks talked about, and Winograd turned it into a verb and an activity and describing what we actually do as human beings.
Next question. Most of the examples given could be seen as examples of poor quality management. What is the relationship between ethics and quality control? Put it differently, if I do proper quality assurance, have I done my ethical duties?
Okay, Marty's quiet. Marty, you want to take it or shall I?
Go ahead, Don.
All right. One of the things that's interesting is the fatal premise leads us to think that we're good people and we have done ethics. And when I've used examples like this, some people just say it's a quality issue. We've just forgotten to do it. And the issue is, yes, you've forgotten to do it because you failed to consider the impacts on other stakeholders. Quality control is often restricted to functionality. Now consider the examples. That airplane crash, the system met the functions and met it in appropriate time, and the project was delivered, and it would pass quality control. Consider error messages on a system. Well, if an error message stops things in the middle of a surgery, it was an appropriate error message, but it didn't consider the impact on the stakeholder laying on the table with a surgical knife in their stomach.
So I think what you're emphasizing, Don, is that it depends on what you call quality. If you include all the ethics considerations that you described as part of quality control, then the answer is yes. And if you don't, the answer is no.
You said it more efficiently than I did.
Next, we have a question from Twitter. How diverse is your ethics committee, and how are you raising and amplifying Black voices with your ethics efforts?
How diverse? Go ahead.
Yeah.
Marty.
So on our ethics committee, we have I think a good mix of men and women. I think it's about 40% women, 60% men. We have representation from Europe and the United States. We are not as effective at amplifying Black voices. We do not, as far as I know, have people of color on our ethics committee. There are, in fact, some I've never met and have never seen.
Some of them are Asians. We have some Asians and some from India.
So the answer is, the short answer here is, we haven't had a lot of volunteers who are people of color.
Yes, they can email us. We'll take all the help we can get.
Yep.
Okay, thank you. Here's a rather involved question, but I think it's worth listening to. Defining ethics via effects is the second design pattern of the Belmont Principles of 1978. They call it beneficence. The others two are respect for personhood and justice or fairness. Like all good design patterns, they are intention to be negotiated, not a checklist to be enumerated. And of course, you said this in your talk. I worry, though, that if defining ethics is only in terms of effects or the public good, how do we integrate fairness and the consent of stakeholders? So do you two think that you've overemphasized the public good and effects and underemphasized fairness and consent of stakeholders?
I think that the sense of impacts on stakeholders is perhaps being narrowly interpreted. One of the impacts on the stakeholders is to deny them the choice of doing things. And in the API example that we gave with Apple and Google, one of the things they did in their consideration, which was an impact on the stakeholder, is give the stakeholder a choice of what information they would include on the notification act. And so there was not an imposition. They tried to avoid imposing things on them. And in the design of the app, they consulted with them. So I think I may be too strong in my use of the word impacts, but one of the impacts is, did I treat you fairly? So I don't think it excludes the things that the questioner suggested they exclude.
I think.
Next question. I'm sorry. Go ahead, Marty.
I have a couple thoughts on that too. One of the things we certainly mention in the code is be fair and take action to not discriminate. And so part of that, I think, stems from a certain amount of humbleness about what we know and what we can do. Yeah, we have our area of expertise, but we need to recognize where the limits of our expertise are. And it's at that point where we start to have those conversations about fairness, about consent of stakeholders, about appropriate representation, and we need to take those opportunities and learn in those opportunities.
So I'm afraid we're running out of time. One of the questions asked something. Could you repeat, Don or Marty, where people can look for the ACM Code of Ethics and other information about ethics and computing?
Sure. ethics.acm.org.
Great. I'd like to thank Don and Marty again for their informative presentation and their insightful answers to many of these questions. A special thanks to each of you for taking the time to attend and participate today. This talk was recorded and will be available online for a few days at learning.acm.org. You can find announcements there on upcoming talks and other ACM activities at learning.acm.org and acm.org. Also, please fill out our quick survey where you can suggest future topics or speakers, which you should now see on your screen. On behalf of the ACM, Don Gotterbarn, Marty Wolf, and me, Keith Miller, thanks again for joining us, and I hope you will join us again in the future. This concludes the talk.